Okay guys, I welcome you to the channel which is about mathematical engineering, the core theory applications. We are dealing some of the problems related to the calculus, algebra, trigonometry, geometry, and we are now dealing with so far with the differentiation, and we are going to start some of the examples as far as the integration is concerned, covering about I can say 3 to 4 videos about integration just from the engineering perspective. And but let's see what we can have for this, evaluating the integral I, which is sine 5 x into d of x. When we're going to solve it out, it would be 1 minus cos square x sine of x d of x, because we have actually breakdown, and also the power has been broken down, and its formula is sine square x into sine square x, and then we have actually done this one. And from that onwards, we're going to a minus b whole square formula. That would be 1 minus 2 cos square x and plus cos 4 of x, and then we have sine of x d of x, and then we have sine of x d of x minus 2 sine x cos square x and plus sine of x cos 4 of x dx. Just put it like this. If I just remove it, this one, so the solution would be how come sine of x d of x minus 2 sine of x cos square of x, or else you can write it like cos square of x into sine x. That would be most cos square of x into sine of x, and then plus cos 4 of x sine of x dx. Now we have to see that how we can resolve it. We have known that sine of x is equal to minus cos x when going to differentiate, so that means removing the integral will convert it into minus cos of x, and plus cos x is equal to minus sine of x. So that means when we have this, so minus of minus, that would be plus, so plus 2, that would be cos cube by 3, so that would be 3 into cos cube x. Then we know that cos x is equal to minus sine x, that would be plus, minus would be minus, so that would be minus over here, then would be cos 5x by 5 plus c is the solution. Okay, this is how you're going to resolve this question. And now I'm going to discuss about another example, which would be number 2 probably. Let's see how we can evaluate the integral which is of cos 4 of x dx, and then we have cos of x that is actually cos of x square of dx. Then we know that cos of x can also be written by as in 1 plus cos 2x by 2 whole square into dx. That would be 1 by 2, 1 plus 2 cos 2x plus cos square 2x into dx. And then you can have 1 by 4 plus half cos of 2x plus 1 by 8, that would be 1 plus cos 4x into d of x. So that would be 1 by 4 of x plus 1 by 4 sine 2x plus 1 by 8x plus 1 by 32 sine 4x plus c. So that would be 3 by 8x plus 1 by 4 sine 2x plus 1 by 32 sine 4x plus c. So this is how you're going to, is the solution for this question. And number 3 would be, just evaluate another question that is of integral 1 over x squared plus x into d of x. That means 1 over x into x plus 1 into d of x, and that would be 1 by x minus 1 by x plus 1 d of x, and that would be ln, if I do it like this, 1 by x dx and minus 1 by x plus 1 of dx, that would be ln of x minus, because this differentiation of x, this one is 1, plus c. You can combine the both like x into x plus 1 plus c. So this is the solution for this part. And for the fourth, integration, this is for integrating by parts. Okay, that is x square x ex square d of x, and then you have this one as u and this one as d of v into d of x. Resolving that, you will able to get minus x of d of x. Actually, integration by parts, you can do it by yourself as well. The formula is very, very simple. And then it would be one over 2 x squared plus c is the solution. Okay, so this is how you're going to deal with it. This one is question number 4. Now we talk about question number 5. And question number 5 would be integral e of x cos bx dx, then again integrating by parts, that would be e of x sin bx over b minus ae of x sin bx by b, and that would be d of x. Now then again integrating by parts, again integrating by parts, you will able to have e of x sin bx by b minus ae of x into minus cos b of x over b square plus a square e ax cos bx by b square over bx. So right hand side integral is just what? A square over b square times the original integral, which is I. So now we can say that AI is equal to E of x 1 over b sine bx plus this would be A over b square cos of bx minus this one is a square over b square, and yet again it would be whole like I. So that would be I, and you can say that as well over a square plus b square b sine of bx plus a cos of bx plus c is the solution. Okay, so this is how you're going to deal with the question number 5 as far as the integration by parts is concerned. And now we're going to deal with the infinite and improper integrals as well, just at the end of this video. Let's see how we can do and perform it for the infinite integral 0 to infinity x square plus a square over square into d of x. We know that the infinite integral can be represented like a to infinity f of x dx, and then you can also have is equal to limit b tend to infinity a to b f of x dx is equal to limit b tends to infinity of f of b minus f of a. That is how you're going to resolve it. That is infinite, indefinite. And now we can say that integral I is equal to limit b tends to infinity, that would be minus 1 by 2 b square plus a square, and that is minus 1 over 2 a square, and that is just solving it out would give us minus 2b square, that would be 0 altogether. Okay, and you can have both the values, so that would give us at the end 1 over 2a square as the solution. Okay, this is how you're going to deal with this one. And when we talk about the 7th one, which is about the improper integral, talking about this directly the question 0 over 2 of x 1 over 4 d of x, that is minus 1 over 4 d of x. That is an improper integral, and we can represent a to b f of x d of x is equal to limit lambda tend to 0, that would be a to c minus lambda f of x dx plus limit epsilon tends to 0, and that is from and this is c, and now we're going to go back again starting from c, and that would be replaced by c plus epsilon and tends to b. Starting from a to b, you just have to consider the delta and the epsilon, and then you can say it is equal to f of x d of x. That is how you're going to resolve it. Okay, this is the improper integral. And now we're going to sort it out. Limit epsilon tend to 0, 2 minus x, 3 by 4, 2 minus epsilon, that would be limit tend to 0, 4 by 3, epsilon 3 by 4, and that would be 4 by 3, 2, 3 by 4, and this is how you're going to say that when it tends to 0, that whole term would be 0, the remaining answer will be 4 by 3, 2, 3 by 4 is the solution. Okay, so this is how it has to be done. Probably this is one of the ways of actually calculating the integration. In the next bit of the videos, we're going to discuss about some of the other techniques about the integration in plane and also in plane polar coordinates. We're going to help you out solve out, and also we're going to find or actually resolve for different surfaces as well, that include the spherical surfaces or rectangular surfaces or even the conical surfaces. Or we're going to actually resolve a different integration, because the main purpose of integration at the end of the day, as the estimation is all about differentiation, or when you talk about differentiation, we talk about the estimation. As an engineering perspective, it is very important, but when we talk about the integration, it is normally covering the area, it is normally covering the problems related to the area of any surface. So that is, at the end of the day, from the engineering perspective, we need to calculate the area of a specific surface at a specific angle probably added, and by that we can able to actually get the information about that particular surface of any shape or of any type. So because we need to know the basic mathematics or even the calculus behind that for that part, so that is why we are going to resolve some of the surface related, integration related problems in the coming videos, so that we can get an idea how that we can achieve, first of all, starting from the basic and just understanding if we come across any complex type of a structure, any complex type of structure, how we able to actually resolve it. But we are not able to actually reach that point unless we don't have the basic capability of understanding what is all about the surfaces. So with this approach, I'm going to end up my video. And till the next video, I hope that you're going to subscribe, like, comment. We have plenty of the channels working side by side for our most of the services that are actually we are willing to provide. The services include the social media marketing. The services include some of the value added services, and also include the online education. You may reach us, and we're going to actually provide you the session as well, and you can book a schedule a session with us of about half to 1.5 hour a day, and that would be 3 days a week. So you can book any session anytime when you want. We'll be able to provide you a session through this platform. So also, if you're willing to have an extra information about our other services, you can visit our channel, which is Nota Bene Tech on Tube. You can go there and you can check about the different type of the approaches we have actually provided through that channel, so that you can see that how you can find us with the help of or you can actually get our services with the help of those videos provided on that channel. And else, if you are interested to have any other information or any other material related to the syllabus, related to the content, especially relating to the engineering domains or different engineering domains, starting from aerospace to aeronautical to aerodynamics, aircraft, and even talking about different other related engineering domains. That includes the mechanical, electrical, electronics, computer networks, and computer engineering. And also you can have the software engineers plugin, and we can able to actually provide you the best of the best online education services, along with providing some of the core material that may help you to actually complete the given syllabus in a given time, and we'll help you actually complete that. Whatever you want to have, we're able to provide. As soon as you are interested, you can reach us through our email, you can reach us through this channel, or even you can just comment us. Else you can share, comment, likes, and subscribe any other channels. We're going to actually provide you the links as well. Till the next video, take care and have a nice day.